Hey everybody, it's Mrs. Slauson. We are back and we are still in our first section in our pink packet of notes. If you want to grab your note packet, I'm on page 54. This is like my millionth attempt on trying to make this video. So what's happening here is you're going to notice I don't have the notes in front of you because I'm going to start with the calculator. What we're going to have to do is we are actually in the middle of page 54. I'm looking at the notes right now. And our goal is, if you look at the bottom, there's a graph. There's these four boxes, but above it, there's an equation. And what I want us to do before I switch to the note packet is get this shape graphed and get all our key points. And normally we would do this on the graphing calculator, but Desmos is just so much faster about this, and not everyone has the graphing calculator. So you have two options. One, you can just watch, or you could pull up another device and go through Desmos with me. So what I've already done is, again, at the bottom of the page above those four boxes, there's a function. It says f of x. It wants us to graph it. And I have already typed this in. So if you want to pause the video and try this on your own, you can. And then if you look to the right of it, you're going to see an x, and then there's a -8 and 8 in brackets. And then a little bit further down, there's a y with -150 and 350 in brackets. And those are just telling us what our x-min and x-max and y-min and y-max are. And you can easily do that in Desmos. You just hit this little wrench, and then you go down here to x-axis, and I just type in -8, hit the tab button, go to 8. The step is just, what do we want steps to go up by? So I'm just going to have it go up by 1. So that means it's going 1, 2, 3, 4, 5. And then for the y-axis, I will start it at, it says -150 to 350. And the step I'm going to have it go by is tens. So, I mean, what if you typed in ones? Well, I don't know if it really matters, so I'll just put in 10 in there. But I can see, whoops, now I just zoomed out. Anyway, the idea is we just want to see the whole graph. So if we're not quite following those restrictions on Desmos, that's okay. All right, so let me fix this one more time. So the reason why Desmos is so great is normally we'd have to go into second, trace to that calc option, and the button pushing would take forever, and we just don't have that time. So once you get this graphed and you can see the full shape, so going back, we'll talk about why the shape is what it is in just a moment. I just want to get this graphed. So if you touch somewhere on the graph, you're going to see your x-intercepts, you're going to see your turns, and then down here, there's actually 2 points if you notice. The one on the left, the one that you're seeing right now, that's the actual low point. And if you go just a little bit to the right, that's the y-intercept. And that's what Desmos does. We don't necessarily need the y-intercept. Sometimes it is a good point, but that's why here we're going to use the one on the left. So what I'm going to do is now switch to the note packet, and I'm going to draw this on there. But normally you could do this without me. Just draw the shape, and then the expectation is you write what you see. You write the 3 numbers behind the decimal. We're not going to be doing any rounding. Okay, so I'm going to stop this video for just a quick moment so I can switch so you can see the paper now. Okay, so what I've done is taken this little bit of space here and I've drawn the shapes and I've marked all my x-intercepts, where it turns, and then my end behaviors. And again, I should know this shape. So let's actually take a look at the function. So what this is saying up here is, so let me back up now. The first part was just to get the shape, is that we are working with polynomial functions. So functions that are going to be higher degrees than the second power and the third power that we've already worked with. And what all of this is saying up here is that this needs to be in standard form. So the highest power, the fourth, to the third, to the second, to the first, to just the constant. And that to know the shape, we always want to look at the leading term, okay? And the leading term is going to tell us the shape. So the 4, which is kind of hard to see now, that even power means we're going to have a U shape, which is what we talked about in the last video. And the negative says it's just going to be flipped. So if you notice, we have that overall general shape, but since we have some other terms behind this leading term, we're going to start to see some waves or bumps in our upside down U shape, okay? So instead of drawing this many, many times, we'll just put our answers in the box instead of drawing it. So let's go through these first. So on what intervals is y greater than 0? And normally in the past, we knew this as, what are our positive intervals? Where are all the y positive values? And the if we just kind of go through, there's positive and negative, and there's increasing and decreasing. So if we just start and we work our way left to right on the graph, this is negative, and then we have a huge positive stretch, and then we have a negative stretch, and then we will look at increasing and decreasing. Here it's increasing, now it's decreasing, increasing and decreasing. So for positive, we're going to focus on that if this is negative, this whole wave area here is positive. And remember, you always write the x value of where it starts and the x value of where it ends. So it starts at -4 and it's positive until it hits 6. And this is where we have to decide between parentheses and brackets, and positive and negative is usually parentheses. So let's go for decreasing. So that's the opposite. Remember, we've got increasing, decreasing, increasing, decreasing. So we're going to have 2 decreasing areas. And again, we write the x values of where it's decreasing. So it starts at this -2.593 until it hits this -0.092. And then it happens again, because now it's increasing at 4.185 to infinity. And again, we're just using parentheses. All right. So let's do the zeros. So the zeros are, wherever it crosses the x-axis, and we just write their pair, the ordered pair. So -4, 0, and 6, 0. And remember, zeros are whenever the y values are 0. And then determining the end behavior, I shouldn't even need to know to graph this. I should know because it's an even power. It's some type of u. Again, along the way, there are some bumps, but it's negative, and so it's upside down. So I should be able to fill this one out without graphing it. Whoops, I'm not writing things correctly. So as x is getting bigger, what's f of x doing? Well, it's going smaller, so -infinity. And then when I write it again, but I put in -infinity instead for x, it's still getting smaller. Okay, and remember, if I'm going too fast, just pause and you can catch up. Okay, so we have some more, so I'm going to have to be bouncing back and forth between 2 pages. So here we want to find the minimum value. So the minimum value is, this lower turning point. And we don't write the coordinate, we write like this. So there's a min value of, and then I write the y amount. So, sorry, where am I looking? This 47.817. And then I say when x is, and then I write the x value. So this negative, sorry, you can't see that, 0.092. All right, these others, oh my goodness. This is going to be a little tougher because the last time I tried to switch over, I lost my microphone. So these 3 we might end up just doing in class together. I don't know. I'm going to see what happens. But yeah. Hold on, I'm going to pause the video. So hopefully you're seeing the screen, and if you're not even going to know any of this because I've restarted the recording. Anyway, so what I want to do is I'm going to take a look at F, G, and H. And so I'm going to start not necessarily in the order that they're going. Where I'm going to start is with H. We want to determine the values of x where f of x equals 200. And remember, f of x is just another 200 here. F of x is just what y is. So normally we would go to our y equals on our graphing calculator and put in 200. On Desmos, what you do is you just go up here, you put in the 200 like that, and then you have to type in equals y afterwards so you can see that. And again, I'm just looking for those points of intersection. So I want to find the x values when y is 200, and that's going to be this 2.639, which I'm going to be writing on my paper. And then I'll show you the final product when I'm done. I get 200, but then it happens again over here on the right, so at 5.278. Okay, and I'll show you how those answers look in just a moment. So that's H. The next thing I'm going to take a look at is G. I want to evaluate at 2.4. So if you go up here to this settings, you can actually create a table if you want. So what I don't need is this 200. I'm going to get rid of that by Xing out of it. And when something's in blue in here, I can type in any number that I want. So remember, when the number's in parentheses, when that 2.4 is in parentheses, that's what X is. And I can just type the 2.4 in and get what the Y value is. So again, I'm just going to write this down on my paper, and you'll see what all of these answers look like in a moment. And now I'm going to go to F for average rate of change. And you're going to notice on F in the brackets is -2 and 4. And so those are the X values. So I'm going to use the table to find my Y values when X is -2 and when X is 4. And I can use any of these rows, but here's -2 and here's 4. And so I get those numbers. Again, I'm going to write them down. And in just a moment, I'll be switching back to the paper. Okay? So give me a moment and I'm going to switch over. All right, so notice this is how I wrote my answers for H. This is when we had that horizontal line going across. This was the X value, here's its Y, here's the X value, here's its Y. And then this is when I use the table, when X is this amount, here's the Y. And then, so again, you can pause, get those written down, and then here's our average rate of change. So average rate of change, I'm not done with this. Remember, this is slope, where I have to subtract my Y's on top, and my X is on the bottom, so 4 minus -2, and then I would just get my calculator out, which I'm doing right now, even though you can't see that. So I'm subtracting my numerators, and I get 192, and then when I subtract my denominators, I get 6, and then I just need to divide those down. So 192 divided by 6 on my calculator, and I get 32. And then that's my average rate of change. So I just think, again, that Desmos goes a lot faster than the graphing calculator. So we're going to try one more, and I'm going to go back to Desmos, and I'm going to be putting this one in. First, I'm just going to get the shape, and then we'll come back to the notes and answer those. So here we go. I'm going to pause and get this typed in. All right, so I've already typed it in, and remember, if you go to this little wrench over here, your toolbox, I just typed in my X min and X max. That was the same, -8 to 8, and I did my Y min and Y max. And that changed. If you didn't change this, that was okay, because the idea is we still see this overall shape. So what I want to do is get those key points. So again, I can just touch somewhere on the graph with my mouse, or if you have a screen, touch screen, and I want where it turns, and anytime there's an x-intercept. And so what I'm going to do now is get this drawn on my paper. I'm on the example below. And then we'll switch to the paper here in just a moment. So what I'm going to do is take a moment and graph this. All right, so I've graphed it. Again, you always want to include all the numbers that they show. We always want to go 3 numbers behind the decimal, and then I put my end behaviors on here. So again, I should know this shape. I should be able to determine the end behaviors. Just let's jump to this one without even graphing this, because this is an odd shape. So remember, an odd shape is some type of line. So normally a line traditionally goes uphill. This odd power, you know, puts some bumps into it along the way, but the negative flipped it. So the negative, instead of going down on the left, it's going to go up on the left, and instead of going up on the right, it's going to go down. So just remember that an odd power is some type of line, and then if it's negative, it flips it, just like a negative slope line would be going down. This is like a negative slope wavy line. So again, if I could just take these arrows and just straighten it out, if this were string, I'd get this overall shape. So let's start with, what letter is that? E, determining the end behavior. So we write this big mammoth thing out. So if X is getting bigger, f of X, I have it over here. So as X is getting bigger, my Y's are getting smaller. And then I'll do this again, but for X to -infinity, and here's f of X right here, and that's getting bigger. Okay, let's go through. I might as well just jump to F. So find the real zeros. Again, the zeros are whenever it crosses the x-axis, and I actually realized that I left the one out. So perhaps you didn't. So I have -1.318, 0. I have 4.934, 0, and then I have some other one, which I forgot to write down, I have another 1, 0. So you write that down. Hopefully you did not mess that up like me. So for C and D, we will have to go back to the Desmos calculator. So we're going to hold off on those. Let's go back to A and B. So we got increasing and maximum. So the maximum is the high point where it turns. And again, we don't write the ordered pair. We say there's a max at, and then I write the Y value because Y being up or down determines, you know, the max or the min. So 29.256 when X equals this 3.477 number. And then the increasing, so its opposite is decreasing. So here we're decreasing, then increasing, and then decreasing. So I only have one increasing interval, and it just starts at this X value and ends at this X value. So I'm going to write those down. Up to here. And now I'm going to go back to my Desmos and I'm going to get these key numbers here. So again, when you see this, this is one X value and I'll need its Y value. This is the other X value and I'll need its Y value. And then this is saying when Y is 30. So normally on the graphing calculator, we would just make that another Y, Y2, and put 30 in. So let me jump back to Desmos and we'll do that. So give me 1 second. So the one I'm going to start with is actually on D, and then I'm going to move to C because I don't know how to start a table and then get rid of the table. So what I want to do is for D, I want to start another Y value, and I put 30 in first, and then I hit equals Y, and you're going to see your line appear. And if you notice, I got a dot here, but I don't have a dot here because this is actually right above that U shape. It looks like it's touching from our viewpoint, but it's really not. So this dot is the only place where they're answering or where they're meeting. So what I'm going to do is write this answer on my paper, and then you can see what it looks like. So I want the X value, so I'm going to write this down. That's that negative 1.967. And now what I want to do is I don't need this anymore, so I'm going to X out of it, and I'm going to go up here to my setting, and I'm going to choose the table, and I need to know when X is, what was it, -3. And I'll go to another one and just change that one to 5. And I'm going to write down their Y values, and then I'm going to come back to the notes and finish this problem up. Okay, so pausing for a moment. And just going back to D, this is the X value that goes in the parentheses, and here's the Y value. And then here are my ordered pairs, and now I'm just going to do the slope formula. So I'll put the Y's on top, and the X's in the bottom, subtracting the same way. So 117 take away -3 is 120. And -3 take away 5 is -8. And again, an average rate of change just takes that down to 1. So I'm just going to divide those on my calculator, which you're not seeing, and I get -15/1. And then that's the final answer. So those are the rest of the notes from 4.1. That's it.